Welcome to lesson 4.4. In this lesson, we're going to solve some even more complicated trig equations. So here's some tips and tricks to help you as we go. We're going to start by factoring. Anytime you have something that is squared, it's probably going to be a factoring problem, so we're going to start by bringing everything to one side and trying to factor it. We're also going to think of our identities. That's going to be a big one for today. And of course, as always, using our unit circle. So with that, let's look at our first one. We have 3 sine cubed of x equals sine squared of x. Notice, this is already a quadratic. We've got squareds and we've got some cubes going on, cubic. So that means I'm going to start by bringing everything to one side and trying to factor it. So I got this. Now, to factor it, this one has a greatest common factor. They both have a sine squared in common that I can take out. So when I take sine squared out of the first one, I'm left with 3 sine. When I take sine squared out of the second one, I'm left with a 1. Now that it's factored, I set each individual factor equal to 0 and solve. So we're going to square root over here, get rid of the squared, and we can do the arc sine of both sides to get rid of the sine. So I get x equals arc sine of 0. So let's go to our unit circle and figure out where is the sine or the y value 0. Where is the y value 0? The y value will be 0 at 0 radians or pi radians. This is also technically 2 pi, but we don't want to include 2 pi. It has a parentheses, so we're not going to worry about 2 pi. So for this first one, I get x is 0 radians and pi radians. Those are the angles where the sine or the y value is equal to 0. Let's try the other one. Add 1 to both sides. Divide by 3. And take the arc sine or the inverse sine to get x by itself. And you'll notice pretty quickly, 1/3 is not a unit circle point. So this part of the problem you would do with a calculator. Remember to make sure your calculator is in radian mode. We'll always be in radian mode for the rest of this lesson. And we're just going to type in arc sine of 1/3 to see what radians we get. So when we type that in, we should get 0.339. Remember, this is 0 radians. This is pi halves radians, or about 1.57 radians. So 0.339 radians would be pretty close to the x-axis down here. Like that. However, we know there's always a second triangle. We're focusing on the sine value this time, so we are looking for the triangle that has the same y value because we're focusing on sine. So the triangle that has the same y value would be over here. And I want this blue angle that will get me to that triangle. I know that this is 0.339. So to find the blue angle, I do pi minus 0.339. And that should give me the blue angle of 2.802 radians. There, I'll do it in blue so it's the same color. Now, one last thing to note. In the last lesson, we had things where it was like 2x equals these things. So we had to list all the solutions, divide everything by 2, and then list the ones out that are between 0 and 2 pi. You only have to do that when there's something with the x. In this case, the x is alone on the inside, so that means the answers we found are our only answers. So once again, if it was something like sine of 2x equals blah, 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 then you would need to do the all answers and do 2x equals, list your all answers plus 2 pi k sort of thing, divide them all by 2, and then list the ones between 0 and 2 pi, like we did last lesson. If there's nothing inside with the x, all you need to do is find your angles on your unit circle, because your unit circle is between 0 and 2 pi. So if you find those angles on the unit circle, those ones are your answers. So that's our first problem. Let's come down and try another one. Here we have secant squared of x equals tangent of x plus 3. Notice this is our first problem where we have multiple trig functions. I have secant happening here and I have tangent happening here. Now, one thing to note, we don't like when there are multiple trig functions. We don't like that at all, not one bit. So the first thing I'm going to do is use a trig identity to get these to all be the same trig function. So I either need to change secant squared to something with tangents, or I need to change tangents to something with secants. Hopefully, when I said I need to change secants to squared to something with tangents, you thought of your Pythagorean identities. Because from the Pythagorean identities, we know that secant squared is 1 plus tangent squared. And from here, we see, hey, look at that. I have a quadratic. I have a tangent squared and a tangent. So now I'm going to bring everything to one side and factor it. Now, I want you to try this part on your own just like we did. So bring everything to one side, try to factor this on your own, and then come back to check your factoring and see how you did. Let's see how you did. So I brought everything to one side to get this right here, tangent squared minus tangent minus 2, and I need to factor that. Now, if you're not sure how to factor with trig functions, use u substitution from 1050. So I changed this to u squared minus u minus 2. And this is often a lot easier to think of factoring than with the tangents. So if I just think of it as u squared minus u minus 2, that gives me u minus 2 and u plus 1. Those are our factors. So now that I've got it factored as u minus 2 and u plus 1, I can put the tangents back in anywhere there's a u. So instead of u minus 2, this becomes tangent of x minus 2. And instead of u plus 1, it's tangent of x plus 1. And now you're fully factored. Once you're fully factored, then you're going to set each factor equal to 0 and solve them individually. Once again, I would like you to try this part on your own, set them each individually equal to 0 and solve them. I'll tell you one of them will be a unit circle problem and one will be one with your calculator. So try this part on your own. Make sure you find both triangles each time. You should end up with 4 answers. 2 unit circle answers and 2 calculator answers. So pause the video, try this one out on your own to finish solving all the way, and then come back to check your work. Let's check how you did. So I solved this one, and tangent of x minus 2 equals 0 to get x equals arctan of 2. I know that 2 is not a unit circle tangent value, so this is the calculator problem. So I just typed arctan of 2 into my calculator. I got 1.107. Now I graphed that right here. There's 1.107. And because this is tangent, I know the other triangle will be right down here, quadrant 3. those are the two triangles that have the same tangent value, which means this angle will also be 1.107. However, I don't want to find that angle. I want to find this angle, which is going to be pi plus my 1.107. So that's what I did right here to get 4.248. So those are the two angles I got from my calculator from this part of the equation. Then I went over to the other side. Tangent of x plus 1 equals 0. Solve that and I get x equals arctan of negative 1. That's a unit circle point. I know where negative 1 is on the unit circle for the tangent values. So tangent is negative 1 here, and it is negative 1 there, which would be at 3 pi fourths and 7 pi fourths. So that is my other two answers. So that is our first two examples of solving some more complicated trig functions. These two examples were both really good examples of needing to factor our trig functions, where anytime we have bigger powers, squareds, cubes, things like that, you always start by trying to factor it. Or even if you have squareds but they are different trig functions, use your Pythagorean identities to change them to the same trig function and then factor them. In the next video, we're going to talk about what happens when the insides are the same. So we have the same trig function, they're both cosine, but this one's a 2x and this one's a regular x. And we'll talk about that in the next video.